Welcome back. If this is your very first time, you're welcome. Make sure you follow right now. In this video, I just don't want to solve. I want to teach you something. If this is your very first time of seeing this rule, this is called the Cramer's rule. Okay, we can use that to solve simultaneous equation. It's a linear algebra method. Okay, as you can see here, this one says if you want to find, let's say if we have x and y variable in an equation, simultaneous equation, you want to find x and y. These are the formulas. For x, as you can see here, is dx over d, and for y is dy over d. Where dx is the determinant of x, dy is the determinant of y, and d is the main determinant. And I'm going to explain while I solve. Okay, so you have an equation here which says 2x plus y equals to 3, x minus y equals to 6. And the reason why I have chosen this simple equation, because if we use just the elimination method, we can get the answers easily. So which is why I've used that, and you can use that for any simultaneous equations. Okay, now for Cramer's rule, for you to find d, this which is the determinant of the main determinant, you just take the coefficient of the variables here. You have 2, then you write 1 here, so this is 2, and this the coefficient of this is 1. Then you come down the other row, you have 1, then you have minus 1. Okay, then you draw this one. Okay, now you find the determinant. How do you find the 2 by 2 determinants? Okay, so you multiply this, you multiply the diagonal matrix, then you subtract this one. So from the top, from the bottom right to the top left, this is the main, this is diagonal determinant. Okay, diagonal matrix, and the other one is the non-diagonal. So this gives you 2 multiplied by minus 1 minus, you see 1 multiplied by 1. Okay, and this gives you minus 2 minus 1, which is minus 3. Okay, so keep that. Then now, when you want to find dx, which is the determinant of x, what you do, you replace this column here, as you can see, with these numbers. Okay, that's what you should do. So this becomes 3. So this becomes 3. Then you have 6 here. Then you maintain these ones. Okay, so you have 1. Then you have minus 1. This again, you find the determinant of that. Okay, so remember you multiply this, then you subtract this one. So you say 3 times minus 1 minus 6 times 1. So this gives you 3 times minus 1 is minus 3, minus 3 minus 6 gives you minus 9. Keep that. Then you say dy. For dy, now you maintain this one, then you replace this one with these variables. So you have 2, you have 1 here, then here now becomes 3, 6. Okay, this again, you find the determinants, you multiply this, say 2 times 6 minus 3 times 1, or 1 times 3. This gives you positive 9. Okay, now once you have that, you apply the formulas. Okay, so if you are applying the formulas, this x here becomes dx. Your dx is minus 9 divided by minus 3. So what do you get? Your answer here becomes, this negative cancels negative, your answer becomes 3, right? Positive. Then your dy again, your y becomes, what is your dy? Your dy is positive 9 divided by minus 3. This gives you minus 3. So those are your answers. Okay, now let's say you want to just use the elimination method. Positive y and this is negative y, they cancel out. What is left here? This is 3x if you add, and this one gives you 9 here. Okay, so you divide by 3, your x is still positive 3. Okay, once you get that, you take one of the equations to find y. You say x minus y is 6, but x is 3 already, minus y equals to 6, right? So if you say minus 6 here, this and this goes. So you have 3 minus 6 minus y equals to 0. If you add plus y here, plus y, this and this goes. So your y is 3 minus 6 gives you minus 3, which is the same answer here. Okay, so that's how you use the Cramer's rule to solve simultaneous equation. If you've learned anything from this, please be sure to follow. So even 3 by 3, you can actually solve that as well. Okay, see you guys in my next video. Bye bye.